All right, let's get right into it. Today, we're cracking open the hood on two really interesting cryptocurrencies. Bitcoin, the original giant, and Kaspa, a super fast newcomer. We're going to see how they both use this idea called proof of work, but in totally different ways that could really change the game.
So here's the big question, right? The fundamental puzzle for any digital currency. How in the world do you build something that is absolutely bulletproof secure, but also fast enough to actually use and is completely decentralized? This is what everyone calls the blockchain trilemma, and it's exactly what we're digging into.
Well, the secret sauce, or at least the most battle-tested recipe so far, is this really brilliant concept called proof of work. It's the magic ingredient that builds trust and keeps everything safe in a system where you're not supposed to trust anyone. Kind of cool, right?
Okay, let's break this down. To really get why proof of work is such a big deal, you have to understand the main headache it solves: how to create trust when there's no bank, no company, no one in charge looking over your shoulder.
At its core, proof of work is basically a massive global competition. You have these participants, we call them miners, and they're all burning real electricity using real computing power to solve a super hard math puzzle. The key is work. You have to prove you actually spent the energy. The winner who proves their work gets the prize, the right to add the next batch of transactions to the official record.
So just imagine this: thousands of computers all over the world, all racing at the same time to find the answer to this one puzzle. The first one to get it digitally shouts, "I got it," broadcasts their new block to everyone, and gets to add the next page to the ledger. Then everyone else checks their work, and the race starts all over again. It's this relentless competition that makes the whole thing so secure. And that, of course, brings us to the OG, the one and only Bitcoin, the project that started this whole revolution. Bitcoin's version of proof of work literally wrote the rulebook and became the gold standard for security in this space. The absolute best way to picture the Bitcoin blockchain is to think of a single-lane country road. It's simple, it's predictable. Each car or block has to follow right behind the one in front of it. There's no passing, no cutting in line. And that rigid, one-by-one structure is precisely what makes it so incredibly tough to cheat.
So let's get a little nerdy for a second. Bitcoin uses an algorithm called SHA-256 for its puzzle. Its structure, like we said, is that one-lane road. But here's the wild part. It was designed to be slow, on purpose. A new block only gets added about every 10 minutes. That slow, deliberate pace is its superpower, because it makes changing the history of the chain almost impossibly expensive and difficult.
Okay, so now let's fast forward. A new player comes on the scene called Kaspa, and the people behind it basically looked at Bitcoin's design and asked a really interesting question. What if we could keep that incredible security, but turn that single-lane road into a massive superhighway?
And this is where things get really, really cool. Kaspa doesn't use a single chain. Instead, it uses a structure called a block DAG. So forget the country road. Now picture a 10-lane superhighway. Blocks can be created and added all at the same time, in parallel. They don't have to wait in line. The real magic is how the network instantly weaves all that parallel traffic into one perfectly ordered history.
And the speeds are just staggering. Kaspa is built for this parallel structure, and its block DAG allows for an incredible 10 blocks per second. Now you're probably wondering, how is that not just total chaos? Well, it uses this genius protocol called GhostDAG. You can think of it like the network's air traffic controller, sorting all those incoming blocks on the fly. The result? Confirmations happen almost instantly.
Okay, so we've got the single-lane road versus the superhighway. Let's put them head-to-head to really see what these different approaches mean in the real world and for the future of this tech.
So it all boils down to this one crucial difference: structure. Bitcoin is serial, one block after another in a single file line. Kaspa is parallel, many blocks all at once. And that one fundamental shift in architecture is what allows Kaspa to scale up and handle a massive amount of traffic without even breaking a sweat.
To really hammer home just how different they are, I want you to look at this number, 6,000. What does that even mean? It means that in the same 10 minutes that the Bitcoin network is carefully producing just one single block, Kaspa has already created and confirmed 6,000 of them. It's just mind-boggling.
I mean, just look at this. It's not even a competition in terms of speed. One block versus 6,000? We're not talking about a small improvement here. This is a completely different league. And the craziest part is, it achieves this massive leap in performance while still being secured by that same core principle of proof of work. So after all that,
let's just zoom out for a second. What's the big picture? What does this journey from a single line of blocks to this parallel web of blocks really tell us about where all this is going? Let's recap the main points. First, proof of work is still the bedrock, the foundation of security without a central boss. Second, Bitcoin proved it could work by choosing to be slow and steady to be unbelievably secure. Third, Kaspa took that foundation and basically strapped a rocket to it with its block DAG design, showing that incredible speed is possible. And what this really proves is that the old blockchain trilemma, it's not a law of nature, it's an engineering challenge, and brilliant people are finding new ways to solve it.
And that leaves us with a really exciting final thought, doesn't it? If Bitcoin proved that this wild idea of decentralized security was even possible in the first place, and Kaspa is showing us that it can also be lightning fast, well, it just makes you wonder, what's the next big breakthrough? What will the next evolution look like? It's going to be fascinating to watch. Thanks for tuning in.